Sequences and series sigma notation. The Greek capital letter sigma is used to signify a sum. We tend to write limits above and below. So looking at the first example, sigma we can see, then r equals 1 beneath, 5 above, which means we want to sum the first term, second term, third term, fourth term and fifth term. So to do that we need to know what each of those terms are. Well, we're given the rule 2r minus 3. So when r equals 1, 2 times 1 is 2, take away 3, minus 1. When r is 2, 2 times 2 is 4, take away 3 is 1. Moving on to get our next few terms, we'll see that they are 3, 5 and 7. So we have our first 5 terms. They total to give 15. Now some of you might have spotted that that was an arithmetic series, so we could have used the formula for that. However, it's easier just to add the 5 terms. On the second one, you'll notice we go from the third term to the 7th term. So we need to find what the third term is. The third term is 5 times 2 to the power 3. So 2 to the power 3 is 8 times 5 is 40. When r is equal to 4, 2 to the power 4 times 5 is 80. And getting the rest of the terms, the next one is 160. Then 320. And finally 640, which gives a total of 1240. Moving on. Sometimes you can see the next one. So when we see sigma r equals 1 up to n for the term 1, well that is the same as 1 plus 1 plus 1, and we do that n times. So it is actually just n times 1, which simplifies to n. So that gives us the first result. Looking at the next one, from r equals 1 to n for r, well that means when r is 1 we do 1, when r is 2 we add 2, plus 3, plus 4, etc. all the way up to the nth term. Well, hopefully you can see that this is an arithmetic series. First term is 1, the common difference is 1, so the sum of the first n terms is n over 2, 2 times the first term, which is 2, plus n minus 1 times the common difference, which is 1. Simplifying that gives us n over 2, and inside the brackets we get n plus 1. So therefore, the sum of the first n terms, using sigma notation, between r equals 1 and n, for r is equal to n times n plus 1 over 2. So to give an example of that, if we want the sum of the first 100 terms, in sigma notation, that would be from r equals 1 to 100 of r. Well, we could just apply the formula here. So it is 100 times 101 divided by 2, which gives a total of 5050. Example 17. In this one, we have sigma, so we're summing from r equals 1 to 20, so the first 20 terms of the series which has a rule 4r plus 1. Now it is always worth trying to write the series out first of all. So 4 times 1 is 4, plus 1 is 5, 4 times 2 is 8, plus 1 is 9, 4 times 3 is 12, plus 1 is 13. So hopefully you can see we're just adding on 4 each time up to the 20th term, which you could work out to be 81. Now hopefully you can spot that this is an arithmetic series. The first term is 5, the common difference is 4. Now using the formula, Sn equals n over 2, 2a plus n minus 1 times d, filling our values in. So the sum of the first 20 terms is equal to 20 over 2, 2 times 5, plus n minus 1, so 20 minus 1, times the common difference of 4, which gives us an answer of 860, answering our question. Example 18. In the first part, we want to find the sum of the series from the first term to the 12th term, given the rule 5 times 3 to the power of k minus 1. So, for part A, let's write this sequence out. Well, the first term is when k is equal to 1, so 5 times 3 to the power of 1 minus 1 is 5 times 3 to the 0, which is 5 times 1, which is 5. Working through to the next one, we have 5 times 3 to the power of 2 minus 1, so 1. So the first term was 5, the second term is 15, and this is the summation, so we need a plus in between. To find the next term, we have 5 times 3 squared, which is 5 times 9, which is 45. And we could keep going there, but we hopefully have spotted that this is a geometric series. So the first term is 5, and the common ratio is 3. And you can confirm that 15 divided by 5 is 3, 45 divided by 15 is also 3. So the summation formula, so Sn equals A brackets Rn minus 1. So I'm using this one because the common ratio is bigger than 1. So filling those values in. So the sum of the first 12 terms is equal to 5 times 3 to the power of 12 minus 1 divided by 3 minus 1. So that gives the sum of the first 12 terms being 1,328,600. In part B, we can see that we have a summation from the 5th term to the 12th term, and using the same rule as part A. So just to think about this one first of all, we want the first, well, previously we worked out the sum of the first 12 terms, so let's think k is 1, 2, 3, 4, 5, 6, and 12. So we could think of those as being the terms. This time though, we want the sum of the terms from 5 to 12. Well, hopefully you can see that we already know the sum of the first 12 terms from part A. So actually, if we can work out the sum of the first 4 terms, we can just subtract that from the sum of the first 12 to give us our answer. So let's do that. So the sum from k equals 5 to 12. So we're trying to make sure our working is clear. This is equal to the sum of, from k is 1 to 12. And from that we're going to subtract k is 1 to 4. So the sum of from k equals 1 to 4 is equal to the sum of the first 4 terms of the geometric series, where we have first term is 5, common ratio is 3, this time 4 terms. So this gives us a total of 200. So therefore our answer is equal to 1,328,600. Take away 200, which gives an answer of 1,328,400.